All right, good morning, or afternoon, or middle of the night, or whatever you're doing. Um, we're gonna work on, again, some of the stuff in Learning Target 5A and then also in Learning Target 5C. 5B is gonna kind of be held on until probably next lesson is where we'll start jumping into that. So here we go. All right, the first big idea that I wanna give you today is that, like, we are taking quadratics and doing something to them to get to polynomials. Remember that a quadratic is a type of polynomial, and so if you take one of these and you just multiply it out with another factor, this one is linear, this part is linear, and I know that it's linear because it looks like mx plus b, and we know that that makes a line on the graph. So if I multiply out this 2x plus 1, multiply that by my quadratic here, 3x squared minus 8x plus 5. I'm going to use box method multiplication here because this is just a really good way to visualize what's happening, and it's going to help us get prepared to do polynomial division in the next couple lessons. So what I'm going to do is I'm going to start by doing 3x squared times 2x, and I'm going to get 6x cubed. Continue on. Negative 8x times 2x is going to be negative 16x squared, and so forth. 5 times 2x is 10x. Keep going. 3x squared times 1 is 3x squared. I'm going to do that in a different color, actually. Hopefully you'll see why. Then I have negative 8x times 1, which is negative 8x. And then I have, on its own, 5 times 1, which is just 5. So now, the whole reason I color-coded this is that now I can look at what the like terms are. So I have this, and this are like terms, which is nice. This and this are like terms, and then we have this one all by itself. So I'm going to rewrite what I have here. My multiplication gives me 6x cubed minus 13x squared plus 2x plus 5. And so this multiplication gives you this cubic polynomial. I know that it's cubic because the highest exponent, the greatest exponent, is 3. So a cubic comes from multiplying a quadratic times a linear. We can do sort of a very similar thing, except let's take a cubic and let's multiply it by another linear factor. So same process. I'm going to continue to use box method multiplication because it's going to show us where all of the stuff that we're working with comes from for the entire unit. So I hope that you kind of stick with me on that. 2x cubed times x is 2x to the 4th. Okay, and then let's see what happens when I do 2x cubed times 5. I get 10x cubed. Okay, so what do I get left? I get 2x to the 4th plus 11x cubed plus 2x squared minus 14x plus 5. So this multiplication of a linear and a cubic multiplies together and you get a quartic because the greatest exponent is 4. Okay, so the whole point of what I'm trying to say here is that you should always be able to get to the point where you take a quartic and rewrite it as a quadratic times a linear factor. If you can do that, then we're going to be able to solve a lot of the problems that we're working with. So this is sort of the conceptual, the where this all comes from and the where we're going. I know that we haven't really jumped into a lot of skills yet today, but that's okay. Our whole goal this unit, and I kind of mentioned this on last lesson, a lot of what we're doing is solving for a polynomial's solutions when the equation is equal to 0. And so, like we just saw, if we can write our quartic or whatever other polynomial, depending on the degree of the polynomial, as a quadratic times some linear stuff, remember that this is multiplied together and it's equal to 0. All of a sudden I'm like, oh, you know what? That reminds me of doing factoring and using the zero product property from chapter 4. And then we have some quadratic strategies to solve this part of the equation. So we would have our linear equals 0. We would have this linear equals 0. And then we would have our quadratic equals 0. And this is the part that's from unit 4. Okay, so let's do one. This one, we don't have the skills to do the problem on the previous page, but we do have the skills to do this one. What we saw yesterday is that we can look for common terms in between each of the parts of the polynomial. And so what do I have in common? I have an x squared in common for each part. So what I'm thinking about is what would happen is if I distributed my x squared back through these parentheses, I would have to get out the stuff right here. So what has to be here? It has to be 4x squared minus 12x plus 5. It's still equal to 0 because it was originally, but now we can kind of check. If I distribute back through, then I will get this thing back, and that's what I want. So now check this out. Remember that x squared is equal to x times x, and so I could rewrite this whole thing as this. X times x times 4x squared minus 12x plus 5. And this is a linear times a linear times a quadratic. And that's exactly what I was just mentioning. Like, now we have written this polynomial as a bunch of linear factors multiplied together, and then there's also a quadratic in there. So what can we do now? Well, we can say with the zero product property, we can say, oh look, x equals 0, x equals 0, and we can say 4x squared minus 12x plus 5 equals 0. And now you're like, oh, now I see what we're doing, because this is a quadratic that you can solve using any of those 5 strategies. I think I'm going to pick factoring, because AC is 20 and B is negative 12, and two numbers that multiply to 20 that add to negative 12 are negative 10 and negative 2. So I can go to box method here. I'm just going to focus on this part right now, and then we'll go back to the other factors and talk about all that stuff. So I have a box method problem. I'm going to put my 4x squared here, my 5 here. Remember that the stuff inside the box is supposed to match the quadratic. So I have negative 10x and then negative 2x. What do I have to put on the outside? Well, I'm probably going to have a 5 here because 5 goes into both of these two terms. That means that I have to have a 1 here because 1 doesn't. 1 goes into both of these. Now this is making me feel like maybe there's negatives to deal with because I have negatives here, so maybe I need to have a negative here and a negative here. This all works a little bit better for me because now the rest of this is a little bit easier. So if this is -1, then this has to be 2x. If that's 2x, this has to be 2x. And we just check that 2x times -5 is -10x, and so now we're done. So let's go back to what we have here. We have our x equals 0. We have our x equals 0. These are two solutions that are the same. And then over here we have this 2x minus 1 times 2x plus 5, minus 5 equals 0. Again, we can zero product property here, and we can say 2x minus 1 equals 0, and 2x minus 5, is equal to 0. So solve for x. X equals 1/2. X equals 5/2. Here are our 4 solutions. We have 1, 2, 3, and 4. So our solution list is x equals 0, with multiplicity 2. I say multiplicity 2 because it happens twice when I'm solving this equation. And then we also have 1/2 and 5/2.